My name is Brian Martin. Today I'm going to be talking about Valkey Lab, which is a tool for stress testing Valkey. I am a co-founder and engineer at IOP Systems. I'm really passionate about systems performance. Was formerly working on the cache team and then the performance team at Twitter. So a lot of my background is from that. So as many of you know, Valkey is fast, and that makes measuring it surprisingly difficult. There are a lot of challenges in driving enough load to Valkey, measuring it accurately, and making sure that you have representative workload against it, so you're really measuring what you want to be measuring, like that you're getting something meaningful out of your testing. And we do this because we want to make Valkey even faster. We want to run Valkey in production and understand how much we can throw at it. So this winds up being something that we do a lot. So whenever we're doing a benchmark, we really need to make sure we understand what's being stressed. Are we measuring the right component, or is the client the bottleneck? We need to decide what metrics we're even going to look at. Do we want to look at the P99, the 3 nines, 4 nines, P50? And then we really need to understand when we're looking at a number like a latency number that we know what's actually being measured. There's nothing worse than doing a bunch of benchmarking and realizing that you had the wrong concept in your head for what this number actually represented. And then a meaningful experiment, as I said earlier, making sure that you have the workload characteristics that matter to you. So introducing Valkey Lab, a new tool for measuring cache performance. This is sort of, I've worked on another cache testing tool called RPC-Perf, and Valkey Lab is sort of built out of a lot of the lessons from working on RPC-Perf. So it kind of came with a set of goals coming out the door based on my previous experience. First one was don't be the bottleneck. One of the challenges is making sure that your runtime is very efficient. Valkey Lab is written in Rust. The original version of RPC-Perf was just like a MIO bear-like event loop sort of thing, very fast. As we added more client libraries and support into it, though, we kind of pivoted to using Tokyo, so we could use a bunch of like async crates, like the Redis RS crate, and various other ones. So with Valkey Lab, I wanted to rip all that back out and make sure we had a very efficient runtime. So it's actually based on IOU ring and a lot of custom stuff under the hood. And I wanted to make sure it was measuring the right things, that we were getting timing at the exact points that we wanted. That was one of the challenges with the Tokyo approach, was making sure we were actually capturing the event when the cache responded and not much later. And to run meaningful experiments. So what's being stressed? When validating this, because of course, when you write some new piece of software, you need to make sure it actually works the way you expect it. There are a bunch of things that we can look at to sort of cross-validate our results. So one of those was looking at the valkey-benchmark tool that comes with Valkey. And it's a great basic tool for benchmarking. And so I wanted to see, how does my tool compare against it when running on various AWS instance sizes. So here we see kind of stepping the instance size. Does the performance change? You know, do I basically need more client resources to drive it? So kind of nice to see here that it only improves like a tiny little bit as we move up from whatever, that's like an 8 core down at the bottom. But we can see that Valkey benchmark actually improves dramatically with that first doubling. So nice to kind of see that we're more efficient there. But there are other properties that we can look at and we can sweep and we can try and understand, hey, do we have some other hidden bottleneck here? One of the next ones to look at is like, how do we handle a massive number of connections? This tends to be problematic for both servers and clients. So again, kind of looking at this, and my screen is very small. So we're looking at the throughput as the y-axis as we grow the number of connections. And it's encouraging to see that there's a nice positive gap here, that we're able to drive more load from Valkey Lab than we were with Valkey Benchmark. So it's kind of encouraging. If you've been running results with Valkey Benchmark at high connection settings, Valkey's probably able to take more traffic than that. Another parameter that often matters a lot is what size the objects are. And this is where things started to get a little concerning. Because here we're looking at the latency instead of throughput, so higher is bad. And we can see that Valkey Benchmark, the latency stays really low as we scale out. And with my new thing, latency goes way up. And this is where understanding what you're really measuring comes and it bites us. So what we can do is we can look at this and say, hey, do these results make sense? And to me, they started not to pass the sniff test. And what I mean by that is we go all the way up to a 1 megabyte object at the high end here, and we're on a 15 gigabit link with this size instance. So we can use physics, like we can actually calculate how long it would take to transfer each of these object sizes, and that must be the floor of what our latency is. It can't possibly be lower than that. So let's plot that and see what it looks like. Okay, so there's a problem here. Valkey Benchmark is reporting a lower number for this latency than is physically possible. So what's going wrong? We're not measuring what we thought we were measuring. Valkey Benchmark is actually measuring the sort of time to first byte of the response. It's not waiting for the whole response to be collected and timestamp it then. And that doesn't mean that it's necessarily wrong. It's just not measuring what I expected that it was measuring. Maybe time to first byte is meaningful to you. Maybe you're streaming something out of Valkey and you want to know when your client starts seeing bytes. Like, that's a useful metric to have. But if you're expecting it to be, if you're in a workload where you need that whole response in order to do anything, you're blocked for much longer than that. So, ideally you report both of these things and try and make it very clear to the user of your tool what the metric actually means. So some kind of benchmark checklist, sweeping parameters, which is what I did there, where I kind of iterated across value sizes, connection counts, instance sizes, pick a dimension, and sort of sweep it and really understand what the response curve of the software is. This can help you sort of validate things and reveal like turning points where things start to respond differently. Cross-validation, very important. Use other tools, especially if things aren't making a whole lot of sense. And then make sure you understand what the metrics are and whether it's the right metric for you. You might want time to first byte. You might want total response latency. In terms of measuring what matters, throughput tests, these are, kind of great, classic, throw a bunch of traffic at something. There's a problem there where you might have coordinated emission if you're driving things just as fast as possible, so applying a rate limit so you can really understand what the latency characteristics are is great. There's a thing called a saturation test. These are all Valkey Lab features. There is rate limiting. There's a saturation test thing where we can sort of step what the rate limit is, and we can look at what our latency is at the tail. We can declare some sort of SLO, and we can sort of automatically sweep how much load we're sending against something and stop when our SLO is violated. So this is really great when you're running a production service and trying to promise that your response times fit within a certain latency. And then also Valkey Lab has things like prefill and backfill, so you can pre-warm the cache or you can do writes on miss. This is like really important because it starts to simulate more what a real client might look like in terms of backfill. So quick screenshot. Valkey Lab has a reporting tool in it. It can capture Parquet artifacts and full histograms. And then there's this lovely built-in viewer for analysis. And that's it.
Awesome. Thank you, Brian.